So far, we have been giving a general idea of what deep learning is, and we have gone into a little bit more detail into different aspects, such as what problems can we solve with deep learning, how we use PyTorch to feed models to data, and what does that mean. In the following videos, we will be entering into quite a lot of detail in all of those things, and basically we will be given a very complete example of how we use deep learning to solve practical problems. In particular, we will deal with the problem of classifying images. What images? Well, we acquired images with our drone in our data collection site here in Zhao Mountain, and you can see an orthomosaic showing a bird's eye view of the site. Here is a bit more detail. And we manually annotated, we means experts in the forestry department, where all of these sapalpine bushes were in this data collection site, and these are super important to determine the, let's say, ecological health of the site. So they marked manually where each bush of each species was, and then we built patches automatically, and we'll give quite a lot of detail about how we did that. So we have different species: Matsu, Inutsuge, Kaede, Nanakamado, Kieraboku, and Sakura. Kaede can also be referred to as mini Kaede. And in the following videos, we will take these patches, these small images corresponding to one of the 6 classes, and train a deep learning classifier to classify those images into the correct classes. To begin with, I wanted to give an overview of how we will do that, and I think this will also be good as a general idea of how this works, as a summary of how this works for those of you that don't really want to get into all of the nitty-gritty detail. You can see a bit more detail, but not so much in this first video. And I want also to connect this overview explanation that I'm doing now with the explanation about how to fit models with PyTorch that I did in a previous video. So basically we are going to be using, let me get it here, this Jupyter notebook that you can access in the courses, and this is called Training Deep Learning Models in PyTorch. And basically we started by downloading the data, so you can use that data here we have collected. It's publicly available, and you can download it in the same Jupyter notebook. And we will be given lots of details, but basically first we process that data into all of those small images, patches, and we also take care of being sure about what label, what expert opinion information is associated with each of the patches. We connect that, we give this to PyTorch, to the PyTorch library for deep learning algorithms, using something called the dataset class, and in previous video we entered into quite a lot of detail into that, but we will revisit it in this explanation. But basically we have our data in a way that PyTorch can understand, our small image patches, each representing one sapalpine bush of one of the 6 species, and then we define a model. In our previous example, defining a model was pretty simple. This is the example that we already saw about how to generate data and use PyTorch to feed some model to it. Before, we used to define very simple models. For example, the linear model was just a linear equation, and we defined quadratic and we did not define cubic models, but we gave an intuition on how to define cubic models. We also defined an affine transform model. Okay, so we will need to define our model, and to do that here because we are going to be using a ResNet model, we will borrow a predefined model from PyTorch libraries. Just in case you're curious, the original paper for ResNet is this one by Kai-Ming He and others. It's publicly available in archive. And just to give you an idea of here you have very deep, very detailed description of the whole thing, of the complexity of the model. Here they are comparing some of the models that they are defining, some parts of their model, to other deep learning networks. So they do have quite a lot of, let's say, pieces of modules that connect in very particular and very necessary, interestingly, ways. So we could go and use our Python programming ability to define all of these complex models in all detail and change whatever we wanted, but we don't need to. For this example, we will just be happy to use one of these very famous ResNet50 models. So our model definition will again be very simple because someone at PyTorch already did the job for us. And then the most important part of this this notebook will be how to train that model that we have defined by borrowing a definition. And what I wanted to show you the most here was that training that model is done in exactly the same way as we did in the previous notebook. If you remember, we had an iterative process, so something happened for a number of epochs, and here we will have the same thing. We will have another iterative process. Okay, we will also have epochs, but here they are a little bit more hidden, but basically they are governed by the data loader, and this 4 is the same 4 that we had here. Iterative process, and in each step we are going to first use the model to make predictions. Remember that we used to do that. Here we do it the same. We outputs the model, we create outputs from feeding the inputs to the model, and from these outputs we have several things, and one of them are the predictions. Then we computed the loss function, and we will have to define a loss function. In the previous simple examples we defined it ourselves. Here we will also borrow it from one of the many loss functions pre-programmed in the PyTorch library. And then we also compute the loss function here, and then what we did was backpropagate the loss like we are doing here, backward or backpropagation, and then compute the steps, the parameters for the next step. Okay, here we did it by hand by using gradient descent implemented by hand. Here we are going to make it a little bit more general, and we are going to use an optimizer, but the steps are basically the same. First make predictions with a forward pass by using the model, then compute the loss, and to compute the loss we use backpropagation that computes the gradients of the network, and then we use all these gradients that we have computed to create the parameters for the next step. So basically this structure here to train a super complex ResNet50 model, or a more complex ResNet50 model, is the same structure that we use here for linear regression or quadratic regression. One of the very useful, very powerful things that PyTorch can do is that it's super general, and it can be used in a variety of scenarios. And then we will speak about training and validation and the difference between the two, how to make the functions nice and efficient, and then we will actually go and feed our model and compute our loss functions, the train and the validation functions that we will see in a second. So just to sum up this overview video, first we can download the data. It's publicly available, the data and the annotations. You have them here. These notebooks, download them to a Colab machine, but if you download the notebook doing file, download, and download the Jupyter Notebook format and run it in your computer, you will have the data in your computer. Then we use the data set to visualize the data and pass it to the PyTorch library in a way that it can process easily. We have given already quite a lot of detail into this, but we'll go over it quickly again. Define a model using the pre-programmed functions that PyTorch has for that. Okay, and we will define a ResNet model like this, and then we will learn to fit this model to the data by using the structure that we already saw when we were fitting simple models to do things like linear regression. In the following videos, we will enter quite a lot of detail into these issues.